Our universe is a place of constant motion. Galaxies are rushing away from each other at incredible speeds. This expansion was first observed by Edwin Hubble in the 1920s. Hubble's discovery revolutionized our understanding of the cosmos. It suggested that the universe had a beginning, a moment we now call the Big Bang. The expansion of the universe is not slowing down. In fact, it seems to be accelerating. This acceleration is one of the most profound mysteries in modern cosmology. It has led scientists to propose the existence of a mysterious force called dark energy. Dark energy is thought to be a property of space itself. It pushes everything apart. Working against the force of gravity, the more space expands, the more dark energy there is. This creates a runaway effect, with the expansion accelerating over time. The fate of our universe hangs in the balance. The ultimate outcome of this cosmic tug-of-war between gravity and dark energy remains one of the most captivating questions in science today. Dark energy is a perplexing concept. It makes up roughly 68% of the total energy density of the universe, yet we know very little about its true nature. We cannot see it or touch it. Its presence is inferred from its gravitational effects on the largest scales. One way to think about dark energy is to imagine it as a kind of anti-gravity. While gravity pulls things together, dark energy pushes them apart. This repulsive force is what's driving the accelerated expansion of the universe. The discovery of dark energy has profound implications for our understanding of the cosmos. It suggests that the universe may not be as we once thought. The familiar laws of physics, as we know them, may not hold true on the grandest scales. The study of dark energy is at the forefront of modern cosmology. Scientists are working tirelessly to unlock its secrets. Understanding dark energy is crucial to predicting the ultimate fate of the universe. Let's discuss the 3 ways that we can destroy the universe. Before that, make sure to subscribe our channel to more interesting content. 1. The Big Rip. The Big Rip is a hypothetical scenario. It describes a universe where dark energy's influence grows without limit. In this scenario, the expansion of the universe accelerates at an ever-increasing rate. As the expansion accelerates, the fabric of space-time itself begins to stretch and tear. Galaxies are ripped apart, stars are flung away from their host galaxies, eventually even planets are torn asunder. In the final moments of the Big Rip, the very atoms that make up matter are torn apart. The universe dissolves into a sea of fundamental particles, forever isolated from one another. The Big Rip is a dramatic and violent end to the universe. It is a stark reminder of the immense power of dark energy. Thankfully, current observations suggest that the Big Rip is unlikely to occur. 2. The Big Freeze, also known as the heat death, is a far less dramatic end to the universe than the Big Rip. It is also considered the most likely scenario based on our current understanding of physics. In the Big Freeze scenario, the universe continues to expand forever. However, the expansion gradually slows down as the universe ages. Stars eventually burn out, exhausting their nuclear fuel. Galaxies fade into darkness. As the universe expands and cools, matter is gradually converted into radiation. This process is driven by the relentless increase in entropy, a measure of disorder or randomness. The universe eventually reaches a state of maximum entropy. It becomes a cold, dark, and desolate place. Only a faint whisper of radiation remains, a fading echo of the universe's once vibrant past. 3. The echo of the Big Bang, the Big Crunch. The Big Crunch is a scenario in which gravity ultimately triumphs over dark energy. The expansion of the universe gradually slows down. It eventually halts and reverses. The universe begins to contract, getting hotter and denser as it collapses in on itself. Galaxies draw closer together, their stars colliding in a dazzling display of cosmic fireworks. As the contraction accelerates, the universe becomes a crucible of unimaginable heat and density. Eventually, all matter and energy collapse into a single point, a singularity. This final state mirrors the Big Bang, but in reverse. The Big Crunch is a compelling scenario because it offers the possibility of a cyclical universe. This idea is explored further in the next section, with the concept of the Big Bounce. The Big Bounce is a hypothetical model that builds upon the Big Crunch scenario. It suggests that the universe may go through infinite cycles of expansion and contraction. In this model, each Big Crunch is followed by another Big Bang. The universe is reborn from the ashes of its previous incarnation. This cycle of death and rebirth could continue indefinitely. The Big Bounce is a captivating idea. It offers a way to avoid the finality of the Big Rip or the Big Freeze. However, it remains a highly speculative concept. Current physics cannot adequately explain what might happen at the singularity of a Big Crunch. The conditions would be so extreme that our current understanding of physics breaks down. The ultimate fate of the universe remains uncertain. However, cosmological observations provide clues that favor some scenarios over others. Measurements of the cosmic microwave background radiation, the afterglow of the Big Bang, suggest that the universe is flat. This flatness implies that the universe will likely expand forever. Additionally, observations of distant supernovae indicate that the expansion of the universe is accelerating. This acceleration supports the existence of dark energy and makes the Big Freeze the most likely scenario. However, it is important to remember that our understanding of the universe is constantly evolving. New discoveries could significantly alter our predictions about the universe's ultimate fate. The quest to understand the universe's fate is a journey into the unknown. It is a journey driven by our innate curiosity about the cosmos and our place within it. While we may never know for certain how the universe will end, the pursuit of this knowledge will undoubtedly lead to profound discoveries. These discoveries will reshape our understanding of the universe and our place within it. The universe is full of surprises. It has a knack for defying our expectations. As we continue to explore the cosmos, we must remain open to new possibilities. The universe's grand finale may be far stranger and more wonderful than we can possibly imagine.